Okay, hello everyone. Today my talk will be about what I've been doing this month for fun. Maybe we can first check who already knows what is advent of code, and who ever solved any problem there. Okay, a few. Okay, so okay, so what is advent of code? It's an online coding competition. It's from December 1st to December 25th until the Christmas. It looks like this. Every day there is one new problem released. It has always two subparts, and people have to solve this problem. So as you can see in the background, the web page, you can then see which problems you solved. Okay, it's very popular. Actually, this year more than 90,000 people solved at least one problem, according to these statistics. And for each problem and each sub-problem, the top 100 fastest submissions get points, and there's a global leaderboard, and people are ranked on this leaderboard. There are no prizes, but it's only for fun. Okay, so my plans this year. Previous years I did know this competition, but I never really attended. But this year some of my friends competed, and I said, okay, let's do it. But to be really fun, let's do it seriously. So I set some goals. Let's start every day solving the problem the moment when it's released. And this is at 6 a.m. in the morning, local time. Not my favorite hour, but okay. And my second goal is to be at least once amongst top 100 competitors to solve a problem. Okay, this is how problem statement for day one for this year looks like. There's a lot of description and a story, and how the problem solving process looks like. You read the problem description, you download an input data set. This input data set is generated for each contestant differently, so you cannot cheat by copying an answer from someone else. You write a code that produces the answer, and you submit the answer. And then you repeat the process again for part B. Okay, so it sounds simple, but people are really fast. I don't know if you can see this. I'll scroll down. For example, that problem that I was showing, the first guy solved it in 23 seconds after it was released. And to be amongst 100 to solve this, you had to solve it in 1 minute, 24 seconds. So pretty fast. So how can I actually compete with these guys? Come on. Okay, first thing, we can automatize some parts of our process of solving. Technically, when I'm solving, I should only read the problem and implement a solution. Everything else should happen automatically with a single command. So this basically involves downloading input data, running your solution, uploading the answer, and so on. So I first check the existing resources, if people already implemented such things. And there are quite a lot of implementations, actually. This is a web page that lists many of them. and also solutions of various people and so on. And since my language of choice was Python, I looked for Python tools. So I made a list of Python packages that exist and that I found on PyPI and by Googling. So some criteria by which I decided which one to use is last commit on GitHub, overall downloads, which is available on PyPI, GitHub stars, and which features it supports. And yeah, clearly this first one is the most popular. It supports downloading input, submitting answers. It caches incorrect answers so that you cannot submit the same incorrect answer twice. Because if you submit the wrong answer, you get 1 minute penalty. And it has nice object-oriented interface. So I decided actually to take this package as dependency and build another package on top of it because I wanted even some more functionalities. So I implemented a bit nicer command line interface, added support that you have a template and the initial code structure of your solution is generated from the template, and a few things are already automatically parsed in. Then input parsing, so that you don't get actually string, but for example, list of integers. So this way, this actually helps a lot. Then logging, that you can actually log your process of solving, and afterwards check what you did and where you spent most of the time, maybe create some statistics. Some utilities for testing on various small test cases and so on. But yeah, I'm happy to hear if you have any more ideas what to add. So far I call this package fast AOC, and it's available on GitHub, but it's still in alpha release, so basically it works, but it's missing unit tests, documentation, some features. I intend also to release it on PyPI when I fix all this. So probably until next year, this package will be in really good shape. So it's going public, or at least more public than this next year. Okay, so now we have this, but now we're maybe on the same position as everyone else in the top 100, because everyone else also has some scripts for this. Then the next thing where we can improve is faster reading and understanding the problem. You sort of have to read diagonally. Not everything is important. At least at the beginning you have some story which is not important. So you should focus to bold text and examples at the end. But at the same time, you should also have to catch all the details, because a lot of mistakes then happen if you miss something in the problem description. And you should also check the input data that you have, because first it's important the size of input data so that you can adapt the complexity of your solution accordingly. And it happens in a few occasions that the input data is actually the special case of the solution that a problem would require. And so you can implement easier solution that works only for this special case and get your answer much faster. Okay, and then also faster coding, of course. So the first one is a bit controversial, but you actually have to break some rules of good coding. So for example, you have to use single letter variables to be faster. You're allowed to just copy paste various parts. Yeah, you create a copy pasta solution, but if this solves the problem faster, then implementing another layer of abstraction, it's good. And sometimes you can even create a semi-manual solutions where you do something by hand. And yeah, sometimes it's faster this way. But at the end, you should also refactor your solutions, because some code, you have to actually reuse it for the problems for next days. And you should prepare this. And since we're solving in Python, there are also ways how to speed up the solutions. For example, instead of running it with normal CPython, you can run it with PyPy. Or you can use the number library, but I don't recommend this one because it brings some other problems sometimes. And then, of course, you should, in advance, learn about algorithms and data structures, and also how to implement them as fast as possible, and maybe prepare some ready-to-use implementations of this in advance so that you can then just use them. And then, of course, you should just practice a lot. It turns out that it's probably not enough if you code every day for your job, because that kind of coding is quite different than this one. At least the objective is different. And so you should solve the problems for past years. And there are countless online sites for training where you can just solve the problems and compete on the competitions. This just lists a few. Okay. And this is how at the moment looks the performance of top 100 submissions for each problem per day. So we can see at the beginning, okay, so blue one is part A, the yellow one is part B for the problem. You can see that actually now you can even solve a problem in 1 hour and still reach top 100. But also the problems got a bit more difficult. These are my rankings over this 18 days. So I achieved the goal about 3 times so far to qualify to top 100. But I still have to compete every day until the end at 6 a.m. So yeah, it's not over yet. You can check it out, and happy coding. Any questions?
So how is it possible to solve the first one in 20 seconds? Yeah. It's like, how can you read a sentence that fast?
Yeah, the solution is actually one-liner, and if you have all the process prepared already, I guess you also don't read the entire problem, but just a few bits, and you can really quickly figure out that you have to do just this, and just write this, I guess.
So how long does the process take for you to go to the page, read, download, and do you upload the solution, or do you do this on the website?
So you do only use command line interface. I just say start, and it will automatically download the input data, prepare the template. I just read the problem, implement the solution, and then say submit, and this is it.
But if you don't have this worked out, you do this manually?
Yeah. On the web page, you have to click to input data, copy paste this into probably a file. Then your solution has to read this, and yeah, so on.
You said that this kind of coding differs from your daytime coding. Are there any benefits that you see from this fast coding for your job or your other hobbies?
You can learn about some advanced algorithms and some tricks. Maybe also become a bit faster. Yeah, this is it.
Which are the most common algorithms or data structures that you use during this change? Is there any that you use more often than the other?
Okay, so besides the problems that you just have to implement some instructions, for example, we have dynamic programming, we have with graphs, algorithms on graphs, for depth first search, breadth first search, and yeah, various combinations of algorithms. But at the end, so at least so far, you didn't have to use any really extremely difficult unknown algorithm. You just had to implement it quickly and don't make a mistake.
Do you get to know a little bit beforehand, or do you get just when you start doing?
The problem description.
Yeah.
When you start doing at exactly 6 a.m., the problem is released.
So it starts counting from 6 a.m.?
Mm-hmm.
Do you have a library of algorithms that you use?
I'm not using any of it, but there might be some available. If you want to use such library, you really have to know it in details because there's no time to.
Your personal library of the common
I have some modules where I keep the commonly used code and then just import it. Yeah.
One more question about, so it starts at 6 a.m. for our time zone. What about for New York or?
Well, at the time, I don't know what time is it there. Then, but
Okay, so
it's at the same time everywhere around the world.
okay, so you, in theory, you could take here at 6 a.m. you take the problem, solve it, and then wait for California to wake up. VPN there and submit it.
No. It's at the same time. It's not at 6 a.m. everywhere,
okay.
but the
So it's at midnight in
probably.
New York. Okay.
I'm just remembering that what was it 2 weeks ago was the deep learning presentation. You know,
Mhm.
the deep learning people are going to throw
Oof.
download a spawn of 2 million solutions and find the first one and just upload it milliseconds later.
In 2 million accounts, you mean?
If you're doing text processing, you know, and you're trying to understand it,
Right.
yeah, I don't know how far into the future that is, but you've just got 10 million algorithms. Throw the data in and see which one gives the right answer.
It might take a long time to sift through.
Yeah.
Thousands of cores.
Just finding the right solution, you know. Just
You
picking
deploy them all simultaneously. First one that answers true, upload it.
Yeah, but you know the true solution.
No.
How do you don't know the true solution?
So yeah, I haven't seen any machine learning approaches of solving this, but maybe in the future when language recognition will advance, and then maybe, yeah.
When you press submit, do you get like success?
Yeah. Mm-hmm.
So if you have quack, 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 you just go again and...
Yeah, but you have to wait for 1 minute.
Okay.
Okay.